This video I'm going to talk about Anthony Riley and Numbynumb, their idea of parallax. They're basically saying that these beams on this tower should cross over as the car moves. So car moves. So as the car is moving along, they're saying that these beams should be crossing over. But the thing is, what they don't understand is that this tower over here is a very different orientation, a very different shape than the distant towers. So these vertical beams are only going to cross over at a different point in time because of the shape of the tower and the orientation of the tower. In order to understand this, we'll go into Google Earth and have a look. So let's quickly orientate ourselves again. This red line goes across all the distant towers. Here we have the towers. Bear in mind the shape of the towers. 2 feet for each of these distant towers. 2 feet. It's a very different shape, a very different orientation than the tower that Anthony Riley and Numbynumb are talking about, that is lacking parallax. So here we go. This is the tower they're talking about, it's lacking parallax. And basically, the two vertical beams which they're saying don't have parallax is coming out from this corner and this corner. So you can actually see those vertical beams there and there. So these are the vertical beams coming out of these corners. Now you can immediately see that this yellow line and the red line are not exactly in the same orientation. As you can see, the yellow line crosses the red line and reaches the road at a different position. So someone who's going to be on this road here, he's going to see this red line, meaning the distance tower, cross over much earlier than the yellow line, where the beams, the vertical beams of the square tower will cross over. So now I'm going to give an example at an airport where I'll show this, and then we'll come back to this section here. All right, in this example, I've drawn a line along the center of a runway in Heathrow Airport, and I'm going to be showing how close objects change orientation relative to near objects. So this line will represent the distant towers. And here I've drawn a line in yellow to represent the close square tower, but orientated slightly off. Now I've actually gone to the length to measure the orientation. The change in orientation of this square tower is 3 degrees relative to the straight red line. So if we measure that, we can actually measure that. So let's do this. So from the yellow line to the end of the yellow line, 273 degrees. Let's just try to get that. 273 degrees. Now let's measure the red line. That. Yeah, so about 269 or just 270. So the difference between the yellow line and the red line is about 3 degrees, or slightly over 3 degrees. Which is very similar to the difference between the orientation of the square tower and the background towers. Now I'm going to measure how long this red line is. That's 18 meters long. So this line here, 18 meters. Okay, and let's measure the length of the runway. 3,677 meters, or 3.6 kilometers. All right, let's orientate ourselves close to this red line. Alright, so what I want to show is that this red line, even the distant part of the runway, will cross over all at the same point, but not at the same point as the yellow line, even though the yellow line is much closer. Alright, so let's turn. At this point, the red line is crossing over, and when is the yellow line going to? Around here is the yellow line crosses. Alright, so what I'm showing is that even though the yellow line is much closer than the distant part of the runway, just because it's closer doesn't mean that it will cross over, that its vertical beams will cross over at the same time as the distant part of the runway. So in our analogy, just because the towers are crossing over at this point here, does not mean that the yellow line or the close square tower vertical beams will cross over at the same time. It will cross over when they line up with each other, which is about here. So here, the yellow lines are crossing over. They doesn't cross over at the same time. And another point I want to point out is, look, this line over here crosses over within a couple of meters. From here to here is enough to get the red center line to cross over. So it's just a very small amount of movement, and the very distant towers, 3 kilometers away or even more, will all cross over at the same time, even though they're very distant. Whereas the close line will not cross over, even though it's close. You have to go quite a bit further to get it to cross over. And this line here is the same angle versus the red line as it is by the square tower and the distant straight towers. So now we're in Google Earth where the towers are. This red line is the line that goes along all the towers. This yellow line is the line that goes along the vertical beams of the square tower. Now, this post we can see in Stanley's video at 16 seconds. And as the car drives along, a couple of seconds later, he crosses the distant towers cross over each other, but it takes quite a few meters later till the vertical lines of the square tower will cross. Now the difference between this and this is about 3 degrees. It looks a lot more than that, but it is 3 degrees, and we'll measure it soon. And the distance from here to here is about 25 meters. So let's measure that. This yellow line is 25 meters. So it takes 25 meters from when the red line crosses till when the yellow line crosses. So what we'll do now is let's zoom out and measure this. So this yellow line is from one corner to the other corner. So this is where the vertical beams come out of. So when this line is crossed, that's when the vertical beams on this square tower will cross. All right, and these red lines goes along all the towers. As you can see here, we're going along all the towers. That red line stretches out to the end of the lake. All right, so that's the line that goes along all the towers. And this yellow line is the line that goes along the vertical beams of the square tower. What we'll do is we'll measure this to show that it's about 3 degrees. Take a ruler, zoom in to this corner. All right, as you can see, from one corner to another is about 203 degrees. Now I'm going to put that on the red line, and you can see it's about 200 degrees. So it's about 3 degrees difference between the red line and the yellow line. So this yellow line, 203, that was about 200. 3 degrees difference, just as it was in my runway video. And this shows they're not going to cross over at the same time. He then went along and made another video trying to show parallax, how the front closest object will move the most compared to the distant objects. Yes, it's true the closest object moves the most, but he still is ignoring the fact that the square tower is at a different orientation to the distant tower, so its crossover point will be different. Now, in the previous video, he said that he will delete all the videos against Soundly and apologize if someone can prove how Parallax works, how the vertical beams of the closed tower will not cross over each other. We'll see if he actually keeps his word and deletes his videos against Soundly. Somehow I doubt it.